This video highlights a direct manufacturing process known as direct metal laser sintering. Here we are at Morris Technologies in Cincinnati, Ohio. They are a leader in direct manufacturing by utilizing the process of direct metal laser sintering. Here we see an array of direct manufacturing machines produced by the company EOS of Munich, Germany. This is the EOSint M270 with its accompanying powder filtration carriage. Upon closer inspection, we find that this machine has components that are similar to other machines that you may be familiar with. This is the arm that spreads and levels the powder. Here is where the stainless steel build plate is bolted. Next to it we see the powder feed bin. This is the shroud that houses the laser. This is the lens that focuses the laser. Here we can see a technician bolting down the stainless steel build plate. It's important to make sure the build plate is absolutely level before the build is started. Let's take a look at a few sample parts that are printed with the DMLS process. This is a root to a jet turbine fan blade. It is printed in cobalt chromium, which is considered a super alloy. Notice the detail on the leading edge and trailing edge. These small pinholes help direct fuel and air while the turbine is in operation. Realizing these design details while the part is being grown is one of the major features of the DMLS process. This part was designed with an internal screw mechanism. It would be very difficult to realize this piece with a traditional manufacturing process. This part has been sectioned and remains connected to its stainless steel build plate. Notice the stunning detail of this printed rook. The stairs run from the top of the piece down to the bottom. This is a pulley that has been printed in cobalt chromium. Here is a mini turbine. Notice the extreme detail and functional internal section. Once again, these internal shapes will be very difficult to realize with any typical manufacturing process. Before any part can be printed, support structures need to be built. This is done by using the software package Magix by Materialize. I've chosen to design a ring as my test part. You'll notice that certain sections are flat. With arching sections, I believe that these parts will be self-supporting to a certain degree. You will notice that the majority of the support structure for this part will be connected to the flat portions of the ring. The arching sections of the ring will receive a less robust support structure. One by one, the supports are added until the entire support structure is created. Here we notice the operator manipulating the undersurface of the arch. This will allow for minimal intrusion of the support structure, while in turn improving surface finish and speeding support removal. Once the supports are realized, the part data is transferred to the machine and the build can begin. The operator has just performed a build plate leveling test. Now the powder in the feed bin must be leveled. Once this is accomplished, the build plate can be covered with a 40 micron layer of powder This will take a few passes to ensure that the build plate is completely covered. The interior of the build chamber is filled with nitrogen gas. This ensures that there will be no oxidation while the laser is burning each scan. This first layer is 40 microns thick and will ensure that the laser's first scan will weld the support structure to the build plate. The name direct metal laser sintering is a bit of a misnomer, as the laser actually welds each layer together rather than sintering. Here you can see the laser welding. It gives off quite a spark. The usable build area is 9.5 inches by 9.5 inches by 8.5 inches. Each layer thickness is between 0.001 and 0.004 inches. The machine operates a 20-watt laser with a fine focus diameter of 0.004. This gives excellent resolution to parts. This part is being created with a powder called Direct Metal 20, which is bronze-based. Other materials offered with the DMLS process include stainless steel, cobalt chromium, and titanium. Updated scan parameters include a process known as clocking. This is where the laser changes its angle of approach by 60 degrees with every scan. Clocking reduces part stress associated with the heating and cooling of each layer as it is welded. This results in robust manufactured parts which are actually stronger than their material in a wrought state. This is a major benefit to the direct manufacturing industry. Here the operator begins the extraction process. Notice he wears latex gloves and a respirator to protect him from the unwelded powder. He also uses a vacuum hose to capture any airborne particles. A sifting screen is placed over the powder feed bin to capture any non-recyclable material. All unused powder is captured and sifted through a filtration system. This enables it to be reused in subsequent builds. Similar to an archaeologist, the operator removes the excess powder to reveal the printed part. Once the extraction process is complete, the build plate needs to be unbolted from the machine. After the fine dusting of powder is removed, the joined plate and part are transferred to the support removal area. Before the support structure can be removed, the part must be separated from the build plate. This is accomplished by traditional sawing. Build materials that are more dense than the bronze-based Direct Metal 20 material require a more advanced separation method. One of the methods utilized is the electrical discharge machining, known as EDM. Now the part is ready for support removal. Here is a great shot of the internal honeycomb structure of the supports. Notice the pleasant satin finish, which is characteristic of a freshly printed part. Support removal is a straightforward operation. Here we see a technician snapping off the supports. This is followed by filing and light sanding. Depending on the desired finish of the part, a number of different techniques can be applied. I have chosen to have my part shot peened. The result is a reflective satin finish with minimal intrusion to part detail. Thank you. This concludes this demonstration of the direct metal laser sintering process. This presentation was produced by Anthony Tammaro for the Metals Jewelry CAD/CAM Department of Tyler School of Art, Temple University, with cooperation from Morris Technologies of Cincinnati, Ohio.